On December 27th, 2004, something reached across 50,000 light years of space and touched Earth. You didn't feel it. Nobody did. But it happened. And we'll get back to that because what it was and how close it came to ending everything is the kind of detail that tends to stay with you. For now, here's what I want you to understand about this list. These aren't theories. These aren't fringe ideas cooked up in the corners of the internet. Every single thing you're about to hear has been confirmed by peer-reviewed science, observed by multiple independent teams, and in most cases, still has no satisfying explanation. The universe has rules, rigid, mathematical, brutally consistent rules. And yet, if you look closely enough, you start to find places where reality seems to have forgotten what it's supposed to do. Here are 12 of them. Number 1. It's a Tuesday afternoon in 2009, and a group of amateur astronomers are sitting at their computers, clicking through raw data from NASA's Kepler Space Telescope. Kepler was designed for one thing: watching distant stars for the faintest possible dip in brightness, the kind that happens when a planet passes in front. They'd done this thousands of times. They knew what it was supposed to look like. Then they found KIC 8462852. The star sits about 1,400 light years away in the constellation Cygnus. It's slightly bigger than the sun, slightly hotter, entirely unremarkable in every way, except for what it does to its own light. It flickers, not the smooth, predictable dip of a planet crossing in front of it. This star dims by 1%, 2%, 10% sometimes, by 22% randomly, irregularly, for days at a time, and then recovers. Astronomer Tabitha Boyajian, then at Louisiana State University, later called it the most unusual star she'd ever seen. Stars just don't do that, she said. The scientific community agreed. They named it after her Tabby star. They also called it, informally, the WTF Star. That stands for Where's the Flux? But you probably knew that. Every reasonable explanation was proposed and tested. A cloud of comets, a swarm of asteroids, an uneven debris disk. One team, and this is the one that went viral, suggested something they were careful to call a megastructure hypothesis. Not aliens, officially, just the acknowledgement that if an advanced civilization wanted to harvest a star's energy, this is exactly what the data might look like. Scientists don't say alien megastructure lightly. They said it here. The current best explanation involves dust, an uneven ring, remnants of a destroyed moon, slowly orbiting and scattering the light. It's probably dust. But here's what nobody tells you: the star is also slowly dimming overall. It lost 14% of its total brightness between 1890 and 1989. A century of fading. Dust doesn't behave that way. As of today, no single mechanism fully explains both the short-term dips and the long-term dimming. Tabby's star remains, officially, an open case. Number 2, here's where it gets strange. We know the universe is expanding. That's been settled since Edwin Hubble figured it out in 1929. What's been less settled, much less settled. Increasingly less settled is exactly how fast. There are 2 ways to measure the expansion rate of the universe. The first looks at the cosmic microwave background, the ancient light left over from the Big Bang, 13.8 billion years old, and uses the known physics of the early universe to predict what the expansion rate should be today. That number comes out to 67 kilometers per second per megaparsec. The second method doesn't use predictions. It just measures. It looks at nearby stars, nearby galaxies, the known brightness of supernovae, and builds what cosmologists call a distance ladder, a chain of measurements from our neighborhood outward. That number comes out to 73. Some recent measurements push it to 76. 67 and 73 don't sound that different. In cosmology, they're catastrophic. The discrepancy is 5 sigma. In science, 5 sigma is the threshold for discovery. You could also call it the threshold for a breakdown. It means the probability that this gap is a coincidence, a measurement error. A statistical fluke is roughly 1 in 3.5 million. In January 2025, astrophysicist Dan Skolnick of Duke University stood at a meeting of the American Astronomical Society and said the words, "No cosmologist wants to say the Hubble Tension is now a crisis." The James Webb Space Telescope had triple-checked the measurements. The numbers held. The universe is expanding faster than it should be, faster than the standard model of cosmology allows, and we don't know why. There are theories, early dark energy, unknown particles, something in the fabric of space we haven't discovered yet. None of them have been confirmed. All of them, if true, would require rewriting the foundations of modern physics. Our best model of the universe may be wrong, and we have known this with 5 sigma certainty since at least 2025. Number 3, right now. As you read this, there are worlds drifting through the dark between the stars. No sun, no warmth, no light of any kind, just rock and ice and silence, moving through interstellar space at tens of thousands of kilometers per hour. Worlds the size of Earth, worlds the size of Jupiter, worlds we will almost certainly never find because they emit no light, reflect nothing, and leave no trace except a brief, faint bend in the light of a distant star as they pass in front of it. These are rogue planets, and there are more of them than you probably want to know about. For decades, astronomers suspected they existed planets flung out of their solar systems by gravitational chaos early in a system's history, sent tumbling into the void with no hope of return. In 2023, a 9-year survey called MOA, Microlensing Observations in Astrophysics, completed its analysis. The lead researcher, David Bennett, a senior scientist at NASA's Goddard Space Flight Center, published the conclusion: our galaxy is home to roughly 20 rogue planets for every single star. There are somewhere between 100 billion and 400 billion stars in the Milky Way. Do the math. We're talking about 2 trillion worlds at minimum, wandering alone in the dark. 2 trillion. If you counted one per second, it would take 63,000 years to reach that number. And that's just our galaxy. There are 2 trillion galaxies in the observable universe. But this is the part nobody talks about. Some of these worlds might not be dead. A 2023 study from the European Southern Observatory found that a rogue planet with the right atmospheric pressure and internal heat from radioactive decay, from tidal stress with a large moon, could maintain liquid water on its surface or beneath it for over 1 billion years. No star required, just darkness, pressure, and time. Life, as we understand it on Earth, emerged in less than 1 billion years. A rogue world with liquid water has had more than enough time. Right now, somewhere in the black between the stars, there may be something alive, looking up at a sky with no sun in it, not knowing what a sun is, Not knowing anyone is looking. Number 4. In 2001, a satellite called WMAP, the Wilkinson Microwave Anisotropy Probe, mapped the oldest light in the universe, the cosmic microwave background. The afterglow of the Big Bang stretched thin across 13.8 billion years, cooled to just barely above absolute zero. The map was almost exactly what physics predicted. Almost. In one region of the southern sky, spanning roughly 10 degrees, about 20 times the width of the full moon, the temperature of the background radiation was wrong. Not slightly wrong, not within the margin of error. It was colder than it should have been, in a patch far too large and far too cold to fit inside any standard model of how the universe began. They called it the cold spot. The Planck satellite confirmed it in 2013. It's still there. It has been there since the beginning of the universe, imprinted in the oldest light we can observe, and nobody has a clean explanation for it. The leading candidate is a supervoid, an enormous region of space, relatively empty of galaxies, sitting between us and the CMB in that direction. When light from the background radiation passes through a void, it loses a tiny amount of energy. A big enough void could, in theory, produce the cooling effect we see. Astronomers have found voids in that part of the sky, but none of them are quite large enough, quite empty enough, to fully account for what the data shows. A 2022 study published in the journal Astronomy and Astrophysics looked directly at the lensing signal in the Planck data and ruled out the supervoid hypothesis entirely. There is no void on the line of sight that could explain the cold spot. So what is it? One proposal treated seriously, not dismissed, published in peer-reviewed literature, is that the cold spot is the imprint of a collision. Not a collision between galaxies or stars or anything inside this universe. A collision between our universe and another one. A bubble universe in the framework of eternal inflation, pressing against the boundary of ours during the first fractions of a second after the Big Bang, leaving a bruise in the fabric of the cosmos that we can still see today. Stay with me. This isn't speculation in the way that word usually means. It's a falsifiable hypothesis, consistent with a cosmological framework, eternal inflation, that is taken seriously by physicists at Caltech, Princeton, and Cambridge. We don't have the data yet to confirm it, but we also can't rule it out. The oldest light in the universe has a scar on it. And one of the best explanations we have is that something hit us from outside. If you're finding this useful, if any of this is making you look at the sky differently, hit subscribe. There's a lot more where this came from. And the algorithm won't show it to you unless you tell it to. Number 5. On April 17th, 2020, a burst of radio waves crossed the Milky Way and triggered detectors on Earth. The whole event lasted about a millisecond, less time than it takes you to blink. In that single millisecond, the source released as much energy as the sun produces in an entire year. It arrived from a magnetar inside our own galaxy, which made it the first fast radio burst ever traced to a known object within the Milky Way. That was the good news. We finally had a source. Here's what it didn't solve. Fast radio bursts, FRBs, were first detected in 2007, hidden in archived data from the Parkes Radio Telescope in Australia. A single, powerful, millisecond-long spike of radio energy from somewhere outside the galaxy that nobody had noticed for years because no one expected to look for it. Since then, hundreds more have been detected. Some fire once and go silent. Others repeat unpredictably, irregularly, with no pattern anyone has decoded. The most active repeater, FRB2 0121102A, has fired over 1,000 times. The power involved is staggering in a way that numbers struggle to convey. A typical fast radio burst releases, in a fraction of a second, more energy than our sun will radiate in 3 to 5 days. The most powerful ones outshine the combined radio output of billions of stars, an entire galaxy compressed into a pulse shorter than the sound of a finger snap. And we still don't fully know what makes them. The 2020 detection gave us magnetars as a confirmed source for at least some FRBs. But magnetars don't explain the repeaters. They don't explain the ones coming from elliptical galaxies billions of light years away, where magnetar formation is rare. They don't explain the precise clock-like repetition detected in FRB2 0180916b, which fires on a 16-day cycle with an eerie, almost mechanical regularity. Now, pay close attention. The CHIME telescope in British Columbia, a massive array designed specifically to catch fast radio bursts, has been cataloging these events since 2018. Astronomers Shami Chatterjee and James Cordes at Cornell University, two of the leading FRB researchers in the world, have said publicly that the field is still wide open. Multiple physical mechanisms almost certainly produce these bursts. Magnetars are one. What the others are, we genuinely don't know. Something in the universe is making these signals, frequently, powerfully, from every direction. And it is doing so in ways that a single explanation cannot cover. The universe is talking. We don't speak the language yet. Number 6, every galaxy in the universe is spinning too fast. Not a few of them. Not the unusual ones, the outliers, the exceptions astronomers tend to dismiss. Every galaxy, all of them. By all the physics we know, Newton's laws, Einstein's equations, everything we have verified to extraordinary precision here in our own solar system, they should be tearing themselves apart. The stars on the outer edges are moving so fast that the gravitational pull of the visible matter alone cannot hold them. The math says they should fly off into space, but they don't. Something is holding them together, something we cannot see, cannot touch, cannot detect with any instrument we have built. Something that does not emit light, does not absorb light, does not interact with ordinary matter in any way we have yet found, except through gravity. We call it dark matter. It makes up roughly 27% of everything in the universe. The ordinary matter, every star, planet, gas cloud, you, everything you have ever seen or touched makes up about 5%. The rest is dark matter, and something even stranger called dark energy, which we'll leave alone for now because it deserves its own nightmare. The name dark matter was coined by Swiss astronomer Fritz Zwicky in 1933 when he noticed that galaxies in the Coma cluster were moving too fast for the visible mass to explain. Nobody took him seriously for decades. Then, Vera Rubin, an astronomer at the Carnegie Institution in Washington, spent years in the 1970s mapping the rotation curves of spiral galaxies, painstaking, unglamorous work that most of her colleagues considered unimportant. What she found confirms Zwicky completely. The outer edges of galaxies were moving at the same speed as the inner regions. That is physically impossible unless there is far more mass than we can see a vast, invisible halo of something surrounding every galaxy in existence. Rubin's work changed cosmology. Dark matter became the consensus. And yet, here's what most people don't realize. We still don't know what dark matter is. Not even approximately. We know it must exist because the alternative that our laws of physics are fundamentally broken seems worse. We've run underground detectors in mines, looking for dark matter particles passing through the Earth. Nothing. We've built detectors in space. Nothing. The Large Hadron Collider at CERN has smashed particles together at energies that would have revealed most proposed dark matter candidates. Nothing. 27% of the universe, the majority of all mass in existence, and we have never once, in 90 years of looking, directly detected a single particle of it. It is there. It has to be there. And it is completely invisible to us. Number 7, right now, without your knowledge, without any sensation you could perceive, you're being pulled, not toward the ground, not toward the sun. Something far larger is doing the pulling, something so massive, it is drawing the Milky Way and the Andromeda Galaxy and the entire Virgo supercluster and hundreds of other galaxy clusters spanning hundreds of millions of light years in every direction, all of it. The whole neighborhood of the observable universe we call the Laniakea supercluster toward a single point in space. At 600 kilometers per second, that's 2.2 million kilometers per hour. Every hour, you are 2.2 million kilometers closer to something you have never seen and cannot see. We call it the Great Attractor. It sits roughly 250 million light years away in the direction of the constellations Centaurus and Hydra. And here is the problem. It sits almost perfectly behind the densest part of the Milky Way's disk, behind the dust, the gas, the blinding core of our own galaxy, the zone of avoidance, astronomers call it, the place in the sky where the Milky Way itself blocks our view of what lies beyond. For decades, the Great Attractor was pure inference. We could feel the pull. We could measure the motion of thousands of galaxies all streaming toward the same point, but we couldn't see what was there. When astronomers finally punched through the obscuring dust using X-ray and radio telescopes, wavelengths of light that the dust could not block, what they found was the Norma cluster, a vast, dense knot of galaxies, one of the most massive structures in the known universe. And even that, it turned out, might not be the whole story. Deeper surveys have suggested that the Norma cluster itself may be part of something even larger, a concentration of mass called the Shapley supercluster, 600 million light years away, which may be the true gravitational engine behind the motion. We are falling. We have always been falling towards something that kept itself hidden behind our own galaxy for most of human history. And here is what genuinely unsettles me about this. The Milky Way will never reach it. The expansion of the universe, the same expansion driving the Hubble tension we talked about earlier, is carrying everything apart faster than gravity can pull it together. We are falling toward the Great Attractor, and the Great Attractor is simultaneously moving away from us. And both things are true at the same time, forever. The pull is real. The destination is unreachable. You are moving towards something you can never arrive at, and the universe does not consider this a problem worth solving. Number 8. Now I want to go back to where we started. December 27th, 2004. It's a quiet Monday. Most of the world is still processing the shock of the Indian Ocean earthquake and tsunami that had struck 2 days earlier, killing over 200,000 people. In space, something entirely different was happening. something that had actually begun 50,000 years ago on the far side of the Milky Way in the constellation Sagittarius, a neutron star already among the most extreme objects in the universe. Packing the mass of the sun into a sphere 20 kilometers across had reached a breaking point. This particular neutron star was a magnetar, an object surrounded by the most powerful magnetic field ever measured anywhere in existence. A field so intense, it would strip the information from the magnetic strips of every credit card on Earth from a distance of 150,000 kilometers. Its name was SGR 1806-20 for unknown reasons. On that day, 50,000 years ago, the magnetic stress building inside the star's interior finally exceeded what the crust could contain. The surface cracked. A starquake, the neutron star equivalent of an earthquake, but on a body so dense that a teaspoon of its material weighs 1 billion tons released in a single convulsion. What followed lasted 1/5 of a second. In that 1/5 of a second, SGR 1806-2 released more energy than our sun has radiated in the past 100,000 years. The fireball expanded outward at close to the speed of light. The burst was 100 times more powerful than any magnetar flare previously observed, so extreme that when the light finally reached Earth 50,000 years later, on that quiet December morning, it was still strong enough to partially ionize our upper atmosphere. It compressed Earth's magnetic field. It temporarily blinded several satellites. It physically rang our planet like a bell. From 50,000 light years away, Brian Gainsler, the Harvard-Smithsonian astrophysicist who led the observation of the afterglow, put it plainly, if SGR 1806-2 had been located within 10 light years of Earth, a close neighbor, by cosmic standards, the gamma ray flux would have been sufficient to strip away the ozone layer and trigger a mass extinction. The nearest known magnetar is about 1,500 light years away. We found out afterward that the December 27th event was almost certainly a once-in-a-lifetime occurrence, possibly a once-in-a-lifetime of the star occurrence, an unrepeatable accident of stellar physics that happened to send its energy directly toward Earth, from directly behind the core of our own galaxy, arriving on a morning when nobody was watching the sky. It's most likely that nothing like it will happen again close enough to matter. Most likely. If you're still here, and I hope you are, because what's coming in the final 4 items is where this list stops being merely unsettling and starts being something harder to name. Consider subscribing. The algorithm buries this kind of content. If you don't tell it you want more, 1 click, it costs you nothing. Number 9, there is a wall around you that you cannot see, cannot approach, and cannot ever escape. It's not a physical wall. There are no bricks, no edges, no surface you could press your hand against. It is a boundary defined by time and light and the expansion of space itself, a sphere roughly 46 billion light years in radius, centered on wherever you happen to be standing, beyond which no information, no signal, no photon of light will ever reach you. We call it the Observable Universe. And here is what makes it quietly terrifying. The universe is almost certainly larger than what we can see, possibly infinitely larger. But the space between us and everything beyond that boundary is expanding faster than the speed of light. Not because anything is moving through space faster than light, but because space itself is stretching. carrying distant regions away from us at a rate that cannot be outrun. Any light emitted from beyond that boundary today will never reach us. Any civilization that exists out there at this moment is permanently invisible to us, not because they're hiding, not because the signal hasn't arrived yet, but because the laws of physics have drawn a curtain across the cosmos that will never open. And here is what gets worse. The boundary is shrinking. As the universe continues to accelerate its expansion, as dark energy pushes everything apart at an ever faster rate, galaxies that are currently visible to us will eventually cross that horizon. Their light will redshift into invisibility. They will vanish from our sky, not because they were destroyed, but because the space between us grew too fast. Astronomers at Harvard and the Lowell Observatory have calculated that in roughly 150 billion years, the night sky will be nearly empty. Every galaxy outside our immediate local group gone. Not exploded, not dead, just unreachable, invisible, as if they never existed. Future civilizations, if any exist, will look up at a nearly empty sky and have no way of knowing the universe is as vast as it is. The evidence will have expanded beyond reach. They will think they are alone in a small, quiet cosmos. They will be wrong, the same way we might be wrong about things we cannot yet see, and they will have no way of knowing it. Number 10, August 15th, 1977. A radio telescope called Big Ear, operated by Ohio State University, is scanning the sky as part of SETI, the Search for Extraterrestrial Intelligence. The telescope runs automatically, printing data onto continuous paper. Nobody is watching in real time. 6 days later, astronomer Jerry Amon sits down to review the printout. The data is columns of numbers and letters, representing signal intensity at various frequencies. Most of it is noise, flat, unremarkable. And then, in a single column, he sees something that makes him reach for a red pen. The signal had risen to 30 times background intensity, far beyond anything natural that could explain it. Peaked for exactly 72 seconds, and then dropped back to nothing. It arrived on a frequency of 1.42 gigahertz, the frequency of hydrogen, the most common element in the universe. If you were designing a signal to be recognized by any civilization that understood chemistry, you would use exactly this frequency. Amon circled the column and wrote one word in the margin: wow. The signal has never been detected again. Over 46 years of follow-up observations, using increasingly powerful equipment, pointing at the same patch of sky silence. In 2016, a team from the Center for Planetary Science proposed that the signal might have been caused by a comet passing through the field of view, vaporizing hydrogen gas as it passed. The explanation was disputed by multiple researchers and has not achieved consensus. Here is what remains true, regardless of the explanation, for 72 seconds. In 1977, something produced a signal on the hydrogen frequency from a direction in the constellation Sagittarius of a power and profile consistent with what we would expect from an intentional transmission originating outside the solar system. It happened once, it left no repeat, it left no trace. The WOW signal is the closest thing to confirmed extraterrestrial contact in the history of SETI. And the most terrifying thing about it is not what it might have been. It's the silence that came after. Number 11. In July 2022, the James Webb Space Telescope released its first deep field images. Humanity's most powerful eye turned toward a patch of sky the size of a grain of sand held at arm's length, and found the thousands of galaxies, stretching back almost to the beginning of time. And then the data came back, and cosmologists went quiet. In the early images, Webb detected galaxies that appeared fully formed, massive, and mature, the kind of structures that should have taken billions of years to build at a point in the universe's history when the universe itself was only 300 to 500 million years old. Not billions, hundreds of millions. In cosmic terms, these galaxies were structured, enormous, and ancient before they had any right to be. Astronomer Garth Illingworth at the University of California, Santa Cruz called it, with careful scientific understatement, a little bit of a problem. Ivo Labbe at Swinburne University of Technology in Australia, who led one of the key early analyses, described galaxies so massive that if confirmed, they would challenge our entire understanding of how structure forms in the early universe. They were confirmed. As of 2025, multiple independent teams using Webb data have verified the existence of what researchers informally call impossibly early galaxies, objects that, under our current model of how the universe evolved after the Big Bang, should not exist at the time and place where Webb found them. Some researchers have proposed that star formation was more efficient in the early universe than our models allow. Others have suggested the standard model of cosmology, the same model already cracking under the pressure of the Hubble Tension, needs fundamental revision. Webb was supposed to verify our picture of the early universe. Instead, in its first year of operation, it began dismantling it. Number 12. The universe is 13.8 billion years old. That is a very long time. Long enough, by every calculation we can run, for intelligent life to have arisen not once, not twice, but potentially millions of times across the observable universe. Long enough for a civilization that emerged just 1 million years before ours, a blink in cosmic time, to have spread across the galaxy, colonized thousands of star systems, and made itself unmistakably known. We have found no such civilization. Not a signal, not a probe, not an artifact, not a structure, not a single unambiguous sign in all our searching that anything has ever looked up at the stars from anywhere other than Earth and chosen to reach out. This is the Fermi Paradox, named after physicist Enrico Fermi, who in 1950 asked a question over lunch that nobody has satisfactorily answered since, where is everybody? The silence has explanations, dozens of them. Perhaps intelligent life is simply rare. Perhaps civilizations tend to destroy themselves before they can expand. Perhaps the distances are too vast for any signal to survive. Perhaps they're out there but listening, not transmitting, waiting the same way we are waiting. Perhaps, and this is the explanation called the dark forest hypothesis, developed by physicist Lou Sixian. Among others, the silence is deliberate. Perhaps the universe is quiet because the civilizations that survived learned at great cost that making yourself known is the most dangerous thing you can do. Each of these explanations carries its own weight. Each of them, if true, says something specific and terrible about the future of life in this universe. Because here is what you cannot escape. One of them is correct. We are alone. Or we are not alone, and in both cases, when you follow the logic far enough, you arrive somewhere deeply unsettling. If we are alone, the silence means we are an accident in an indifferent universe of almost incomprehensible size. And the odds of our existence were so small they barely round up from zero. If we are not alone, If civilizations have risen and fallen across this galaxy for billions of years before we arrived, then the silence is the message. And silence from something that could speak is the most frightening thing the universe could send us. We began this list on December 27, 2004, the day a dead star reached across half the galaxy and rang our planet without warning, without malice, without any awareness that we were here. A reminder that the universe operates at scales that do not include us in their calculations. A reminder that the most dangerous things in existence are not aimed at us. They simply don't notice us. 12 things that shouldn't be possible. 12 places where the rules broke down, or where we discovered the rules were different from what we thought, or where we simply ran out of explanations entirely and were left standing in the dark, listening. The universe is under no obligation to make sense to us, and it doesn't always. So here is what I want to leave you with. 3 things. The first, the universe is not only stranger than we know it is stranger than our current physics can describe. Tabby Star, the Hubble Tension, the CMB Cold Spot, the JWST galaxies. These are not unsolved puzzles waiting patiently at the edge of science. They are active fractures in our best models of reality. They are data that does not fit. The second, you are living in the most extraordinary moment in the history of human astronomy. The James Webb Space Telescope, the Keim Array, the Nancy Grace Roman Space Telescope, preparing to catalog trillions of rogue planets for the first time in history. We have instruments powerful enough to find the things that break our understanding. We are not running out of answers. We are running out of questions that the old answers still cover. The third, and this is the one I want you to sit with, everything on this list exists at scales that dwarf human life entirely. A magnetar, 50,000 light years away. 2 trillion worlds in the dark. A cold spot imprinted on the oldest light in existence. And yet, here you are, made of atoms, forged in the cores of dead stars, on a small, wet rock orbiting an unremarkable sun, capable of understanding all of it, or at least trying. That is, when you think about it carefully. The most impossible thing on this list. So here's what I want to know. If we found the wow signal again tomorrow, a clear, unmistakable, repeating transmission from somewhere in Sagittarius, would you want us to respond, or would you want us to stay quiet? Think about it. Tell me below. And if any of this kept you up tonight good, it should.